I'd just like to start off with a quick introduction to explain what I'd like to do with this channel. So a little bit of a background about me. I'm a mechanical engineering student at a Canadian university. And what I would like to do is make a series of tutorial videos that might help out other students who are struggling with calculus or other math courses. I've taken a few more advanced math courses, and I'd like to eventually branch out into those if there's enough interest in the calculus series that I'll be doing. But just as a pilot, I've decided to take an integral from a midterm that was given out in a Calculus 2 course at the University of British Columbia. So this is the integral right here. It's nothing too crazy, but if you've never solved anything like this before, or perhaps if you just find that you're not really understanding some of the things that you've been learning in Calculus 2, I'd like to just go through it, step by step, and guide you through my thought process anyway, and how I would solve this problem. So the first thing that I would do is I would split it up into as many parts as I could. As you'll see here, I've just taken the x over and turned the x to the power 4 to x squared squared. And that might not be immediately obvious to you, so don't worry if it isn't. I mean, I've been doing integrals for years, so it definitely isn't something that I would have thought to do when I first started doing integrals. And now the reason why I did this is because if you take a look just at a table of integrals here, you can find an integral that sort of looks like what we have here. And so if you take a look here, we've got this 1 over x squared plus 1 thing happening here. So there's probably a pretty good chance that we have something that's going to end up being arctan of something. So when I start to do integrals, I kind of I go through a process where first I take a look and see if I can evaluate the integral directly. Like, say we have a polynomial function. Next, I'm going to check to see if there's a function that appears with its derivative in the integral. Then if it's a rational function, maybe I can use partial fractions. If there's a quadratic in the denominator, you may be able to use trig substitution. And there might even be a trigonometric identity that will help simplify the integral. And lastly, if none of these apply, we may just have to do straight up integration by parts. So if we take a look back at our integral, we've got an x squared here, and we have an x here. And I'm sure you know by now that the derivative of x squared is 2x, so we see that we've got a function that's appearing with its derivative. So we can try u substitution. So we'll make the substitution that u is equal to x squared. And if we take the derivative of that, we'll get du is equal to 2x dx. And that's not exactly what we're looking for because we've got this factor of a 2 here. So we can just bring it over and say that du divided by 2 is equal to x dx. So now if we take a look at our integral, I've rearranged it here and brought the x over to this side. We see that we've got our du over 2 here and our u in the parentheses right here. So you know what, I'm going to make those substitutions, and look at that, it's simplified to something that looks exactly like the integral from that table. There's no tricks here. That it really is just that simple. This is equal to the integral of 1/2 arctan of u plus c, of course, because the solution to this is actually a family of functions. It's not just going to be one function, since when you take the derivative of a constant, that cancels out. So finally, we're just going to substitute back in for u. We said earlier that u was equal to x squared. So the answer to this integral is 1/2 arctan of x squared plus c.